are some rules, 2 to 3 rules, how to find the determinant of 4 cross 4 order. First we will learn those rules, then we will take an example to understand this concept. So rule number 1 says choose the row or column for expansion having more zeros in it. Obviously when we take determinant, we expand the rows and column. But which row or column we have to choose to find the determinant of 4 cross 4 order for the expansion? So we have to choose the row which has more number of zeros in it. Rule number 2 says if you have no such row or column which has more zeros, then make zeros by using suitable row or column operations. We suppose we don't have any row which has more number of zeros, then we will use suitable row or column operations and we will make zeros just to make our expansion more easier. So this is rule number 2. Rule number 3 says the cofactors corresponding to elements which are 0 needs not to be calculated because their product will be 0. The cofactors corresponding to elements which are 0 needs not to be calculated because when 0 will be multiplied with the determinant will ultimately approach to 0. So there is no need to calculate such cofactor. Number 4 says calculate 3 cross 3 matrix thus obtained by journal method. After this step, we will get a matrix of order 3 cross 3. Then we can simply take the determinant of 3 cross 3 order by the journal method. So let's take an example to understand these rules. Okay, so this is an example of order 4 cross 4. Let's find its determinant. Rule number 1 says choose the row and column for expansion having more rows in it. Just see this determinant. We have no such row which has more zeros in it. So it means now we will apply rule number 2. If you have no such row or column which has more zeros, then make zeros by using suitable row or column operations. Now we will make zeros in the first column. Okay, so here we have 1. We can make 3 zeros here. We can choose any row and any column. I have chosen column number 1. So first we will make 0 in the first position here. So A is equals to, finding the determinant, first we will write it in the determinant form. 2, minus 2, 3, 4. 3, 1, 5 and minus 1, minus 5, minus 3, 1 and 0, 1, minus 1, 0 and 2. Clear? Now we will make 0 here. So how we can make 0 at this position? When we will do R1 plus minus 2 R2, then we can make 0 here. R1 plus minus 2 into R4. Let's check. This is R1. 2, minus 2, 3 and 4. Now multiply minus 2 with this R4. What we have? 1 minus 2 times is minus 2. Minus 1 into minus 2. This is equals to 2. 0 multiply with minus 2, 0. And 2 multiply with minus 4, minus 4. Now we have to add these two operations. So we have 2 minus 2 is 0. Minus 2 plus 2 is 0. 3 plus 0 is 3. And 4 minus 4 is 0. So we have 0, 0, 3 and 0 in the first row. So we have made 0 at the first position, right? And the row in which a change is happening, that row is written first. We wish to bring a change in row 1. So we have written R1 plus minus 2 R4. Okay, rest of the rows will be written as it is. Okay, now let's make a change in R2 and make this 3 0. How we can make it? If we multiply 3 with this 1 and then subtracting these two rows R2 and R4, it will give us 0 here. Let's check it. Next operation is R2 because we wish to bring a change in R2. So first we will write R2 plus, then we will multiply minus 3 with R4 like this. So multiply minus 3 with R4. What we will get? First write R2. This is R2, 3, 1, 5 and minus 1. Now multiply minus 3 with this R4. We have minus 3. Minus minus is plus and 3 1 times is 3. Minus 3 0 times is 0 and minus 3 2 times is minus 6. Now we have to add them. So 3 minus 3 is 0. 1 plus 3 is 4. 5 plus 0 is 5 and minus 6 minus 1. This is equals to minus 7. So the row 4 we have is 0, 4, 5 and minus 7. Rest of the rows will be written as it is. Now we wish to make 0 at the place of this minus 5. So how we can do it? This is minus 5. If we multiply 5 with this row, here we can get 5 and then adding these two rows we can get 0 here. So the operation will be R3 because we wish to bring a change in R3 plus 5 times R4. So multiply 5 with this R4. First write R3 which is minus 5, minus 3, 1 and 0. Now multiply 5 with this row. We have 1, minus 1, 0 and 2. Now we have to add them. We have to multiply 5 with this row. So we have 5 1 times is 5. 5 minus 1 times is minus 5. 5 0 times is 0 and 5 2 times is 10. So adding minus 5 plus 5, 0. This is minus 8. This is 1 and this is 10. So we have third row 0, minus 8, 1 and 0. So rest of the rows will be written as it is 0, 0, 3, 0, 0, 4, 5 and minus 7, 1, minus 1, 0 and 2. So we have made maximum number of zeros in this column. Next what we have to do is the cofactor corresponding to the elements which are 0 needs not to be calculated because the product will be 0. So now we will expand through the column 1 and we will not calculate the cofactor of these zeros. So expanding through column 1, now we will skip this first column and this last row. Now we have this 3 cross 3 matrix. So first we will find, we are expanding through column 1. To find the cofactor of this term, we have minus 1. This is 4th row and first column. And the minor of M41, which means we will skip 4th row and first column. So we have 0, 3, 0, 4, 5, minus 7, minus 8, 1 and 0. Right? So this is, we have minus 4, 4 plus 1 which is equals to 5. So minus 1 5 times is minus 1. Now we will expand. This is, we have minus 1. Now we will take the determinant of this 3 cross 3 order by general method. So here we have the first element as 0. Skipping the first column and first row, now we have these 4 terms: 5, -7, 1 and 0. Then writing this element with a negative sign. Now we have 4, -7, -8 and 10. Lastly we have this 0 and skipping the last column and first row. So we have these 4 terms: 4, 5, -8 and 1. This is equals to -1. Now since this is 0, so when we will take determinant of 2 cross 2 order, this product will ultimately approach to 0. Similar is with this case. Now we will calculate just this term. So this is -3. Now 4 10 times is 40, minus 7 8 times is 56, and minus minus is plus, which is equals to -1 -3. 40 minus 56, which is equals to -16. -1 minus minus is again plus. 16 3 times is 48. Minus plus is equals to minus, and 148 times is 48. So this is how we can calculate the determinant of order 4 cross 4. Let's take another example. So next example is find the determinant of 3, 5, 7, 0, 1, 2, 1, 3, 7, 9, 6, 3, 3, 5, 7, 0. So this determinant is simply equals to 0. Why? Using the property, since we have this row R1 and this row R4 identical. So when two rows or columns are identical, their determinant is equals to 0. So such kind of questions can also come. In such cases, we don't need to undergo through a long procedure. We have to check whether we have any two rows or columns identical. We can simply write its determinant is equals to 0. Okay, so last example we have is find the determinant of 1392, 5843, 0 throughout the row and 2318. So the determinant of this 4 cross 4 matrix is again 0, because we have the property, if all the entries in any row or column are zeros, then the value of the determinant is equals to 0. So this is all about today's lecture.